Okay, so last time we talked about transformations, and we're going to keep going with that today. So I'm just going to say section 2.5 continued. So we looked at how we know whether to make vertical shifts, how we know when to make horizontal shifts. And so I wanted to kind of review that just a bit. So make sure that you have the handout that I gave last time, and if you don't, then just see me after class. I think I have a few extras because you're going to want the handout. See, it's a little blurry. Let me see if I can get it better focused. Sorry about that. I thought that thing was in there. Okay, so the first thing is, based on the handout I gave you last week, what kind of shape will this graph be? So what tells you that, first of all? The fact that it's what? Cubed, right? So I want you to kind of look back at that handout I gave you, right? So before we kind of talk about how the graph is going to be changed or transformed, let's talk about what the original looks like. Because this is something you're going to need to be able to do on test 1. You're going to need to be able to know, what does the original look like then? What change do I need to make? So I'm going to show a dashed line here, right? But this is the parent function, is what we call it. This is the original y equals x cubed. But then we're making a couple changes based on what we have in the equation, right? So what does a plus 4 at the end of the function do? Like whatever the function is, what does adding or subtracting a number at the end do? Good, yeah, it's an up or down shift, right? So this is going to go up 4 units. Okay, what if it would have been minus 4? Then it would have been what? Down 4 units, okay? And then this, notice how this is different, right? Where's the plus 2 this time? It's not at the end, it's where? Inside, right? So I'm going to say this one's outside, right? But this one's inside. And remember, at the end of class on Wednesday, we talked about that horizontal shifts are oddballs, right? They don't really follow the rules that you would expect them to. So rather than being a right shift like you might think, it's actually a what? Left. And of course, it's left 2 units. Okay, so what I like to do is just focus on like a focal point, which for the cubic graph is probably this one right here, right? So I focus on 0, 0, and I'm going to shift that up 1, 2, 3, 4, and then I'm going to shift it left 1, 2. So my new kind of center point is going to be here, but then the curve stays the same general shape. Okay, so I'm not looking like for perfection, I'm just looking for the general look of the graph. Okay, so this would be my new f of x once I've made those transformations. Okay. Okay, so we talked about both types of shifts last time. So, but that is only one way we can change a graph. Another way is to reflect it in some way. So the first type of reflection we're going to talk about is a reflection over the x-axis. And then we're also going to talk about a reflection over the y-axis. Okay, so first thing is, how do you know that you'll need to do this? Like, how will you be able to look at the equation and know that a reflection needs to happen? So notice what I've added into the function. I've added a negative sign to the front. So I'm going to say it's a negative sign outside the function. Is going to reflect your graph or flip it over the x-axis. So we talked about it a little bit last week, but there's 2 parts to these. You got to know, what does the original look like, and then what change am I needing to make? Okay, so let's look at an example. So let's say that I asked you to graph y equals negative square root of x. So what's the first thing we need to know? We need to know what plain old square root of x looks like, right? Do you remember how we explained it? Like, compare it to a parabola. Do you remember? It was pretty close to a parabola, but different in one way. It's sideways, but it's also cut in half. Do y'all vaguely remember that? Okay. Well, no, I'm graphing the original. Okay. So this is just plain old y equals square root of x. But then you're right. We are going to need to make that change, right? So I just meant we need to know what the original looks like before we worry about what the change is. Okay, but then yes, just like what you said, notice this is outside, right? The negative sign is outside, so it's going to reflect it over the x-axis. So the general shape will be the same, but it'll be what? Like, how would you describe what we need to draw? It just needs to be upside down, right? Because it needs to flip over the x-axis. So it's going to go this way instead. So this would be the graph of y equals negative square root of x. Okay, notice I did the first one dashed because it's not really my graph, right? The one that I really want is the solid one. Okay, so what if it would have been like negative x squared? Like a negative sign to the front, but the function would have been x squared. Then you would have drawn a what originally? What shape? Parabola, and then you would have done what with it, just like you did here? Flipped it upside down. Okay, so it doesn't matter what the shape is, we just flip it upside down. Okay. All right, so we also are, like I mentioned a minute ago, going to reflect over the y-axis. So let's talk about how you'll know to do this and talk about how it's different looking from the reflection over the x-axis equation. So what do you notice? There's still a negative sign, but what do you notice about it that's different than it was up here? It's on the inside, right? So when there's a negative sign inside the function, it's trying to tell you to flip it across the y-axis instead. Hey.
How you doing?
Good. Y'all just check in with me after class is over so I make sure and count you here. Okay, so I'm going to underline kind of what's different, right? If we're outside, we're over the x-axis. If we're inside, we're over the y-axis. All right, so let's look at one like this. So what about if we had the cube root of, we need y equals the cube root of negative x. Okay, so again, we really don't start talking about what change to make until we at least remember what the original looked like. So what's the simplest cube root graph I can have, or cube root function? Just plain old what? Well, not for this one, right? Cube root of x, right? Do you remember what that one looked like? So it's a sideways cubic graph, so it curves this way and then this way. Okay, so again, step A is, do I know what the original looks like? Step B is, can I make the change that's appropriate? Okay, so notice this negative sign is inside, right? So it's trying to tell you to reflect over the y-axis. So when you have like two halves, just do it like a half at a time. So in other words, like where's this half going to go that I'm pointing at? It's going to go, instead of going to the right, it's going to go to the what? It's going to go to the left. And then this piece that's going down to the left is now going to go down to the right. Okay, so this would be y equals, and that's not right, cube root of negative x. So what's not right about this that I wrote? I wrote y equals x cubed, but what was actually the original simpler graph? It needs to look like this, right? So it should have been cube root of x. Sorry about that. The graph is right, just how I labeled it was wrong. So notice, like, so far these are kind of paired up, right? Like Wednesday we did vertical shifting, horizontal shifting. And then so far today we've done reflection over x versus reflection over y. Okay. So let's look at one where we might have a little confusion about what to do first. So when you're doing your homework on MyMathLab, some questions they're just going to have you like describe what the graph will do, and then they'll just have you like pick the graph that looks correct, if that makes sense. So it'll be like, what change do you think needs to happen? And you'll say up 5 over 4 to the right 4 or whatever, and then you'll pick the proper graph that does those things. So without worrying about order, okay, let's talk about what changes we will have, right? So what does this +3 do to the graph? It shifts it how? Up 3? Okay. What about this +2 here? It's going to shift it how? Left 2. And then last but not least, what about this negative sign? Remember, where is it? Is it outside or inside? Inside. So what kind of reflection is that? It's still actually on the screen. Reflection over the y, right? Okay. And by the way, it's also going to be a parabola shape. How do I know that? It's squared, yes. Okay. But the question is, like, in which order? Because your graph would look different depending on what order you did these things in, okay? And there is a correct order to do more than one change at the time, okay? Because different orders would change the look of the graph. So different orders would result in different graphs. So I'm going to give you the order that you need to do multiple changes, and then we're going to re-look at this example too. Okay. So here are the order of the changes or transformations. And just know that one of the things on the list we haven't gotten to yet, okay? But I want to stop and make sure we know how to do these. But a good rule of thumb is you're basically going to work from the inside out, kind of like order of operations. We always start with parentheses first, and that's kind of how you're going to handle these transformations also, okay? So the first shift that you make, or change rather, is a horizontal shift. So we're going to look at an example in a minute, and I'm going to describe why that one would be first. Okay, the second thing you're going to do, we haven't talked about yet, but we're about to. Okay, so the second thing you would do, if it applies, is you would do any stretches or shrinks. Okay, so we haven't talked about stretches or shrinks yet, but we will. Thirdly, you're going to do any reflections that you might have. And then last but not least, you're going to do your vertical shifting. Okay. So if I look at example 2 and I do the proper order, okay, so let's look at example 2's graph, but let's go back up and kind of number which order they should go in, right? So what should come first? We have 3 changes, right? We already labeled what they were right here. Okay, so what should come first according to my list here? We should shift how first? Left first. Okay. By the way, notice you would do parentheses first, so it kind of makes sense that that should come first, right? It's kind of on the inside. Okay. And then we don't have any stretches or shrinks, right? We're not there yet. Okay, we're about to be. But then it comes what? Then we reflect. And then last but not least, we shift what? Vertical or up 3. Okay. Notice it is working from the inside out, right? So like here's the most inside piece, and then we went out to here, and then finally here, right? So it's like we're working our way out. So the last thing we do is always the vertical change. Okay, so let's see if we can graph this and kind of keep this straight. The more visual of a person you are, the easier this is probably going to be for you to picture what it will be, okay? So if you're not so much a visual person, that's not the end of the world. It just might mean you need to like take it slow and do it in stages. So the first thing, before I even worry about changes, I'm going to graph the original graph. Okay, and how do I know it's a parabola again? It's squared. Okay, so there's my original. And then kind of like I said before, you want to focus on kind of a focal point. So where would be a good focal point for you to focus on this parabola? Like right here, right? The turning point. We call that the vertex. We'll get to that a little bit later. Okay. But this, actually, we've talked about that, haven't we, in this class, or have we not? Have we talked about problem? Okay, never mind. We will. My classes kind of get run together sometimes. Okay, So this point is where I'm going to kind of focus. Okay, so I'm going to do just what I numbered up here. So I'm going to go how? Left 2. Okay, so now I'm here, and you just kind of hover your pen, pencil, slash, whatever you're drawing with here. Okay, then what are you supposed to do? Reflect over the y. So where's that going to send you? You're at -2, so where are you going to go now? You're going to go over here, right? And then you're going to shift how? Up 3. So 1, 2, 3. So my new turning point is now here. Okay, so think about it. I didn't turn it upside down, did I? I only reflected it over the y-axis, right? So then it's just going to be a parabola that looks kind of like this. Okay, I'm going to try not to run into my writing here. Okay, so I'm just going to write this. I don't want to write the whole equation, but this is the new graph. This is the graph that has been transformed. Okay, so I've seen some students like take it one step at a time. And they're like, okay, I'm going to shift it left 2 and draw it. And then I'm going to reflect it over the y and draw it. And then I'm going to shift it up 3 and draw it. Do you see why that might be a little ugly when you're done with it? You're going to get 4 parabola graphs and you're going to be like, what the heck is going on here, right? So my strong suggestion is for you to try to do it like we just did, like just go slow enough where you take one point and kind of do all the changes. But if you need to, my absolute strong suggestion would be for you to use like different color writing utensils. And then like know that, hey, the one that I put in, you know, dark red is my final one or something, okay? All right, so let's practice a couple more of those. And then we're going to get to the last 2 types of transformations, because there are 6 total types of transformations. We've only talked about 4 so far. This is one of those lessons that if you're going to copy from someone's notes later, it's not going to mean as much to you. It's really more of like an active, like, you interact with me kind of thing. Otherwise, you're going to be like, I don't know where they got that from later. Okay, so just kind of an FYI. Not every day is like that, but today really is. It's more action-based / visual stuff. Okay, so before I even start, I'm going to graph the parent function / the original. Okay, so I want you to get to the point, maybe not today, okay, but in this week sometime, I want you to get to the point where you already know in your mind what shape that is. Okay, so what shape is a square root graph always? A sideways half parabola. Okay, so here's the original, right? We call that the parent function. So now we just need to figure out what changes need to occur, right? So what does this +2 at the end of the thing mean? Shift it up 2 units. Okay, what about that? It's a negative sign, right? So we know it's a reflection, but which kind is it when it's on the inside? Y. So this is a reflect over the y-axis. But then let's go back and make sure we do the right thing first, right? So if you just, again, either memorize these or just think about, I need to work from the inside out, right? So if we're working from the inside out, which one should be first? The reflect should be first, and it is, okay? Followed by the what? By the shifting. Okay, so again, let's focus on a focal point. Most often you can use 0, 0. Okay, so we're going to reflect over the y-axis, but what do you notice? Here's my pen at 0, 0. If you reflect that guy over the y-axis, what happens? It just goes this way, but what happens to this point? Nothing, right? Like it stays on the y-axis, okay? And then I'm going to shift up 2 units. I just need to remember that I actually need to draw it which direction now? To the left. Okay, so this is my new changed graph. Okay. Okay, so let's do one where I don't think that you would be able to use your calculator. You would have to just know the changes, and just to be honest and upfront with you, this is the kind of question I would probably more likely put on test 1, because you can't use your calculator, and I would know if you really know the rules or not, or if your calculator is the one that knows the rules. All right, so given the graph of f of x, which I'm about to draw for you in a minute, I want you to graph negative f of x plus 2 plus 3, okay? And I know that looks weird, but we're just going to take it one little phase at a time, one little change at a time. So first I need to give you the original graph. So let's sketch, maybe go out 4, and we'll go out further if we need to. So I'm going to use some different colors here. I'm going to use green for the original graph, and then we'll use the other graph. So it's going to sort of be a triangle. So put a point at 0, 0, and a point at 3, 0. I didn't mean to put a point there. That was a mistake. And then put a point at 2, 1. And then just kind of draw a triangle from there. It's kind of like it's a lopsided triangle a little bit. So you don't really need to write these down unless you just want to, but here's the points I graphed in case you're trying to copy it. Okay, or you don't have to write them and you can just literally graph them. So let's say I give you this weird looking graph and I tell you I want you to make those changes to it. Now, how come we know it's a function? It definitely is a function. How come? What does it pass? Vertical line test. So that's definitely a function. It's just not one you can put in your calculator, right? I didn't give you an equation for it. But what I did is tell you what changes I wanted you to make, and then we're going to order them, right? So let's just kind of go in any order we want, honestly, because we'll just number them at the end. Okay, what is this plus 3 at the end of this thing going to do? Shift it up 3 units. Okay, what about a plus 2 on the inside? What's that going to do? Left 2 units, good. And then notice this one's different than the previous 2, right? Where's the negative sign? Outside, so what kind of reflection is that? Over the x. So we know we need to make those 3 changes, right? So now let's just figure out which order we go in, right? So again, just work from the inside out. So what's the most inside thing? The left 2 units is the most inside thing. And then what's the next most inside thing? The reflect. And then what's kind of over off by itself? The up 3. Okay, so I'm going to use a different color, and I'm just going to go like 1 point at a time. And we're going to do 1, 2, 3 changes. Okay, so let's take like the point on the left here. Okay, so what do I need to do with this point that I'm kind of hovering over right now? I need to go left 2, which I just did, and I'm here, right? But then if we reflect it over the x-axis, what happens to it? It's on the x-axis. So if you flip it, what's going to happen? Stay, right? Nothing happens to it, okay? But then what's my final thing I need to do? Up 3, so 1, 2, 3, so it looks like I'm up here. Okay, so let's do it to this point now. Okay, so again, we're just going to go slowly until we're sure we have it, right? So we're going to go left 2, which puts me here at 0, 1. And then I need to reflect over the x-axis, so where will that send me? Down here, right? And then what do I need to do for the last step? Up 3. So 1, 2, 3, and looks like I'm right here. And then for the last point, do it again, right? So left 2 puts me here. Then what? Reflect over the x-axis, which does nothing, right? And then what do I need to do? Shift up 3, 1, 2, 3. So it looks like my triangle's upside down, and actually it should be. How come? We reflected it over the x-axis, right? So this, I don't want to write that whole thing, but this is my new graph. Okay. So do you see what I mean by, like, if you know the order, you can just kind of go slowly 1 point at a time, okay? Now again, on my math lab, it's going to allow you to pick which one you think is right. So on the test, you would need to be able to do what I did here and then sketch a basic something also. Okay, so we've talked about 4 types of changes so far. So let's talk about the last 2. They are, in my opinion, the most challenging. But if you'll think about kind of what the names of them are, I promise we can do them. Okay, so if you vertically stretch something, what does that mean? So what does vertical mean? Like up and down, right? So if you vertically stretch or shrink something, that means you're pulling it taller or shorter, right? So it's definitely helpful if you pay attention to the words and know what vertical is. It basically makes the graph taller or shorter. It does not affect the width at all. It just makes it taller or shorter. Taller meaning a stretch, shorter meaning a shrink. So we're going to look at some examples, but this is how you're going to know that a vertical stretch needs to happen. So notice it's not like a plus or minus C, it's a multiplied C. So that's the explanation of what's happening. It's a constant multiplied outside the function. So I'm going to underline outside because I think you can probably guess that there's going to be one for inside too. But it changes the height by a factor of C. So it doesn't change the width, it only changes the height because it's a vertical change. So I'm going to give you two examples, and then we're going to look at two examples where I just want you to explain what's happening. Okay, so I want you to compare 3x squared, and maybe skip a line, to 1/2 x squared. Okay, so what's like common about them? What's common about the two functions I want you to compare? They're all going to be what kind of shapes? They're all parabolas, and how do we know that? Because of the x squared. Okay. The only change, notice, is this number versus this number, right? So notice the 3's being multiplied on the outside, right? And because it's a positive number bigger than 1, this is actually a vertical stretch by a factor of 3. But an everyday way to say that is it's just basically getting 3 times taller. Okay. All right, but what do you think a number like 1/2 is going to do rather than stretching it? It's going to shrink it, right? So this is going to be a vertical shrink. By a factor of what? 1/2? Okay, so in other words, it's half as tall. Okay, so let's practice one because I want to make sure we can actually do this. So let's do another one where you wouldn't really be able to use your calculator. But let's say, given the graph of f of x, I want you to graph y equals 2 times f of x. Okay, so let's stick with a real simple triangle. So first, you wouldn't be able to do this problem without either an equation or a graph of some sort. So let's make an even simpler triangle this time. Put a point at 0, 0, at 2, 0, and let's put a point at 1, 2. So instead of like a lopsided triangle, it's just a nice even triangle. And let's say that I tell you that this is f of x. So again, we know it passes the vertical line test, so we know it's a function. Okay, we also know it's a function because I used function notation, right? If I say f of x, it means, yep, it's a function. All right, so what am I trying to ask you to do to this graph because of this 2 here? Make it taller, right? The official name for that is we're going to vertically what? Stretch by a factor of 2. So when you do your homework, that's the terminology you're going to need to use. But yes, I want you to also know that it really just means make it taller. So if we're making it taller, what's the only value we're really changing, X or Y? We're changing Y, right? So let's see if we can draw the new taller version. Okay, so I'm going to start here. If you double zeros, what are you still going to have? Like, what's twice 0? Still 0, right? So these two guys aren't moving. They're staying put. Okay? But this one has a height of 2, so what will be the new height since I'm doubling the height? 4. Okay, so this will be my new graph. That's it. Okay. So what I want you to notice is what changed and what didn't. Okay. Notice the height changed, but what did not change? Yeah, the width did not change. Okay, but just know that sometimes when you vertically stretch something, and it might appear that it is skinnier, but actually it's really not. Okay, like I should have brought a rubber band on it too. See if I have one in here. Well, picture this as like a curve of some sort. Okay, well when I vertically stretch it, right, I'm going to pull it like this, and doesn't it make it look more narrow? Okay, but actually I'm really just affecting the height. I don't have enough arms to hold that, but the height should stay the same width around, it would just get taller. Okay, so the last and final change, what do you think the last and final change is going to be? If we vertically stretch or shrink something, what else do you think we can do? Horizontally stretch and shrink something. So that is the last change. You remember how the horizontal shifting was a little weird? Well, the horizontal stretching is a little weird too. Okay, so just kind of know that the horizontal changes are a little bit different than you might have expected them to be. Okay, but a horizontal stretch or shrink is not going to make the graph taller, it's going to make the graph what? Yes. Okay, so it makes the graph wider or more narrow, just because I don't think narrower is a word. Maybe it is. Okay, so we don't want to use terms like the graph gets bigger, because my question to you would be, what do you mean by bigger? Do you mean taller or do you mean wider? So we want to use more descriptive words like wide and tall instead of big. Okay, so the first thing is, how will you know that you need to make this change? Notice it looks just like the vertical stretch and shrink, but where's the C? Instead of being outside, where is it? Inside, right? So if you have a constant multiplied inside a function, so I'm going to underline inside. It changes the width, not the height, but the width, by a factor of 1 over c. And that's weird, right? Instead of a factor of c, it's 1 over c. So we're going to look at some examples and you're going to see what I mean by that. So in other words, what this means is rather than multiply the numbers by c, you're going to divide the x's by c. Okay, that's essentially what it means when you have a factor of 1 over c. But I think you're going to see when we look at a couple of comparisons that it really just works the opposite in the way that you might have expected. So skip a line in between these, but let's compare. Let's compare 3x in parentheses squared versus 1/2 x in parentheses squared. Okay, so just like the last one, what kind of shape do we definitely have? Parabola, because of the what? Because of the squared. Okay. How do we notice that these are different than the vertical stretches before it? Where's the 3 and the 1/2, for instance, as opposed to what it was before? They're inside, right? So the difference here is just what I said. It just works opposite in the way that you might think. This is actually a horizontal shrink, even though we might think it would be a stretch. It's actually a horizontal shrink by a factor of 1/3. Remember how I said 1 over 3? So you just basically take whatever number it is and flip it. Okay, so think of 3 over 1 being flipped and it would be 1/3. So the numbers that you may have expected to be stretches are actually what? Shrinks. So what do you think about this guy? We might have expected that to be a shrink, so what's it going to be instead? It's going to be a stretch. Okay, and you're going to flip that fraction too. So what do you get when you flip 1/2? 2. So the way that I remember them is that horizontal changes of all types are just weird, okay? If you think it's going to go left, it actually goes right. And here, when you think it's going to shrink, it actually stretches and vice versa. Okay, so let's look at maybe a little triangle one like we did before. So given the graph of f of x, let's say that I want you to graph y equals f of 2x. So before we talk about what that 2 is going to do, let's all graph what I'm going to show you I want the original to look like. So let's graph -1, 0, 0, 3, and then 2, 0. So just another lopsided triangle. And let's call this f of x. So we know it's a function because it passes the vertical line test. How do we know that it's a horizontal stretch / shrink that we're doing rather than a vertical? Because where's the 2? It's on the inside. Okay, so if it's on the inside, then it's actually a horizontal what? Yes. So it's a horizontal shrink, which might be surprising, by a factor of what? 1 over 2? Okay, so another way to say this is we're just going to go half as wide. Okay, remember it's a horizontal shrinking, so it's not changing height, it's changing width. So I'm going to use my red for this. Okay, so let's start here. Okay, what kind of width does this have, or what kind of x value is this one that I'm kind of pointing at right now have? Width of 2, right? So what will be the new width if we half it? The new width will be 1, right? It'll only be over here. Okay. What about this guy? The current width of this one is at -1, so if you half that, where will it go? It'll go at, not at 0, but it'll go at like -1/2, like literally between 0 and 1, or -1. Okay. But then what about this guy? What's the x value here where I'm pointing? 0, right? That's the y value, right? The x value is 0. What happens if you half 0? What do you still have? 0. So this point doesn't move. And notice, we get a lopsided triangle that is how much as wide? It's basically half as wide, right? So just like we kind of had this statement before, notice that the width changes, but what does not? The height did not change, yes. So I know it's a lot to learn 6 rules, but I like to think of it like pairs of 3 different types of changes, right? We have shifting, both vertical and horizontal. We have reflections, both over x and over y. And then we have stretches / shrinks, both vertically and horizontally. And if you can kind of learn them in pairs like that, I think you should be okay. Okay, so let's do one example that might have like a lot of different changes, and we'll just see if we can kind of go in order here. So rather than us graph this just to save time, I just want you to describe the graph of the following. So let's say it's y equals -2 times x plus 3 squared, and then minus 4. So I don't necessarily want us to graph this, I just want us to describe what we have. Okay, so the first thing is you can go through this in any order you want, okay? You just have to make sure you go back in the end and number them, okay? So I always kind of start here just because it's like the most obvious one to me. So what kind of shifting do we have going on because of the minus 4 at the end? Down 4. Okay, what about the plus 3? Left 3. And then the weird part here is this is actually 2 changes. We have one change because of the minus sign and then another change because of the 2. And that's what I wanted to make sure that we covered one like this. So if we're thinking of them separately, let's start with the negative sign. What does the negative sign outside mean? Reflect over what? Other one? X. But you knew it was a reflection, so you're halfway there, okay? So reflection over x-axis. And then what about the 2? Notice the 2's to the front, not on the inside, so it's going to be a what? Yes, a vertical what? Stretch by a factor of 2. Okay, so let's go through here and talk about which ones should come first. Okay, what has to come first if we work from the inside out? Left 3 comes first. Then what comes left if you're next if you're really working from the inside out? The vertical stretch comes next. Remember, stretches or shrinks are number 2. Then the reflection, followed by the what? The down 4. Okay. So if you had to tell me what shape this is, you would say it's a parabola that's been shifted left 3, made twice as tall, turned upside down, and then shifted down 4. Okay. So that was the one that you would pick if you were doing a homework question like that. Okay, so before we look at something else, just to kind of recap, here's the handout I gave last week. Okay, so you have to know what these original shapes are, and then what do you have to know? How many changes is it possible for us to have? 6 possibilities, right? So you need to know kind of what changes might be made to these particular graphs. Okay, so it's going to take some practice, like there's no question about it. It's going to take some practice for you to do that, but I'm confident with a little bit of work you can get it done. Okay.